Hello, Assalamu alaikum everyone. This is Sabrina Jasmine from Jahangirnagar University. The paper title of my research is Anonymous Author Identifier using Machine Learning. This research is mostly based on stylometry. We know there has been plenty of research done on stylometry since now. Stylometry not only helps to identify anonymous authors for deciding famous document authorship, email classification, and fraud detection, but also helps for court trial and disease detection, and it has its implementation in the cybersecurity sector as well. So cybersecurity companies predict potential attacks on their clients by monitoring deep and dark web forums where actors conspire and discuss potential bugs and vulnerabilities of clients that could be exploited to attack them. There are existing solutions that analyze texts and state if it's a thread purely based on content. These solutions tend to trigger a lot of false alarms because the discussion content is indiscernible from actual thread. The key indicator of authenticity of a discussion being a thread is its author. There are red hot malicious actors who are notorious for attacks in the past, and if we see a threat from them, there is a high chance that it would lead to a potential attack. The catch is the malicious actors cover up their digital signatures effectively, making it impossible to attribute anyone's anonymous threat to a known actor. However, the most intrinsic feature of such anonymous content is the author's writing style. In this paper, we have tried to find out the answer of the question given a collection of documents, how to cluster the documents that are possibly written by the same author. So let's have a look on the contributions in this paper. We used a Barrows Delta technique source code to fingerprint each incoming document, tag it with a matching author. A curated set of function words was used to construct a count vector of length 632. We also used neural network technique that could automatically derive latent features and could correctly classify 85% of our input queries from a balanced dataset. And now we can have a look on the data collection, how we collected our data. We used user comments from Reddit discussion forum as a dataset. Comment dumps from May and September 2006 were processed to form an initial dataset of 73 authors posting at least 100 comments, each on several subreddits. Then these 100 comments from each author were unique, and we splitted it into 60, 20, and 20 shares to make up train, eval, and test splits respectively. The task was to learn a model using the train split and use it to map comments in dev and test split correctly. The dataset was directly used in Barrows Delta technique and also initial version of neural network models. Problem setup and model. For the implementation of author identification, we did the following. A gated recurrent neural network was built to take a sequence of tokens as input, and we converged it to probabilities of two classes, match or no match. Data splits were transformed into a PyTorch dataset that would supply input target pairs of all our neural networks. At first, test input was tokenized using SPACY tokenizer. For the binary classification problem, two random texts were possibly same or different author were concatenated with a ACP token between them. If the inputs were sampled from same author's comments, then they were labeled as match. The mixing strategy argument were used to control logical form sparsity of the output distribution. If ordered strategy was used, the output samples would have more variation and helped model converge faster. The P2NR argument was used to regulate positive match to negative ratio of the output distribution. Finally, nums samples was used to restrict the size of dataset to experiment faster. Experimentation and fine tuning. All experiments were numbered and indexed based on the hyperparameters being used, logs. First version of dataset with 73 authors did not converge at all. After verifying that training pipeline was set up right by performing overfitting tests, we revisited dataset and made the 24 author dataset by cleaning it. The reason for including longer lines only was to expose the encoder with more contents to recognize patterns. We used ordered mixing strategy to increase the variance in the data distribution seen by the model. The model started to converge and the validation set accuracy came out as approximately 62%. We set up another experiment to train the same model using 24 authors' comments, which came out to be approximately 71% accurate. A little more fine-tuning resulted in the personal best accuracy of 85%. Okay, so let's have a look on this figure. The it denotes the training accuracy and loss curves for our model. The first figure denotes the accuracy curve, and the second curve is the loss curve of our machine learning model. The accuracy improved each time we trained the model repeatedly. Inferencing for DBMS. Once the model is trained, it is expected to be general. For this paper, we did not test our model, but our model should work when we want to identify if two texts belong to same unseen author. Even though there is a covariate shift, this model should work because the original 24 authors are selected randomly and the training data is fairly cross-domain. Based on this assumption, the inferencing script source code would give an trained model and a collection of users will be selected with few textual content as feature. The inferencing script learns the mean of each user's writing style representation. So um, that was it from my presentation. You can say that actually the result got improved with time, and we at first of all we used the Barrow's delta technique, which was not good enough, and then we used the neural network that was quite effective, and we got comparatively better result, and the final result was 85% accurate, which was quite good in fact. So if you have any question about the paper, feel free to ask. Thank you so much for being with us in the presentation today. Thank you so much.